All right, on example 003, we've got natural logs inside of the square root, and we've also got x in the denominator. What we want to do on this one is let u be our natural log. So du is going to be 1 over x dx. And there are a couple of ways you could proceed with this. Probably what I would do is multiply the x on both sides, or multiply both sides by x, so you get x du equals dx. And then I have a cat joining me. You get x du equals dx. And now I can rewrite this as integral of, let's see, the top is square root of u. Got an x on the bottom. And the dx gets replaced with x du. And those two x's cancel. So we're left with just integral of square root of u du. Okay, to do this one, what we need to do is rewrite it as, oh, almost forgot to put a box around here, that's very important. I want to rewrite this as integral of u to the 1/2. Now I've got to use the power rule on that. So when you do the power rule on this, you get u to the 3/2 divided by 3/2, or multiply by 2/3. So we get 2/3 u to the 3/2 plus c. And I'm going to rewrite that as 2/3 ln x to the 3/2 plus c. Now that's how I would leave this answer. The textbook sometimes likes to do something a little different. Sometimes they'll rewrite this as ln x root ln x. And that's perfectly fine too, because this is ln x to the first power, and then ln x to the 1/2 power, and altogether it gives you ln x to the 3/2. So I would probably leave it like I have it written above. The book might write it like that, but either way is perfectly fine. Okay, this one. This one might be a little tricky. What's the inside function here? Well, on this one, you've got sine squared times cosine. So sine is going to be my u. Why sine? Because it's inside of that squared function. You know, if you want to, you can rewrite this as sine x squared cosine x dx. And so sine is inside something else. So du here is going to be cosine x dx. And I'm not going to solve for my dx on this one, because now I can rewrite this as integral of u squared. And then this whole thing here is just du. So I get 1/3 u cubed plus c. And replace the u with sine. So I get sine cubed x plus c. Like that. All right, example 5. In this case, my example is, my u is going to be 7x. So du is going to be 7 dx. So dx is 1/7 du. So what do I get here? I get integral of cosine u, and then dx gets replaced with 1/7 du. I'm going to integrate cosine, I get sine. And that 1/7 I'm going to stick on the front, plus c. So you get 1/7 sine of 7x plus c. All right. Okay, this next one. It might not be obvious what our inside function is here. But the thing that's the inside function is the x squared plus 3, because it's inside of that exponentiation function. So what I'll do is I'll let u equal x squared plus 3. du then is going to be 2x dx. And I'm going to do something slightly different on this one, just to show you a sort of a variation. If you look at what we've got up here, e to the x squared plus 3, that's going to be e to the u. X dx, I want to solve for that. So I'm going to get x dx is 1/2 du. So this is my substitution stuff. So e to the, I'll tell you what, I'm going to write this out. E to the x squared plus 3 times x dx. This becomes e to the u. Then x dx becomes 1/2 du. So this is 1/2 e to the u. When you integrate, you just get e to the u plus c. So my final answer here is 1/2 e to the x squared plus 3 plus c. Like that. All right, so that was several examples in a relatively short video. But that's what a lot of these U substitution problems are like. So we'll pick up in the next video with U substitution with definite intervals.